由 Martin 来为我们介绍讯息分析工具 Message Analyzer。
Okay, let me talk about what I'm going to talk about, if that makes sense. I want to talk in a little detail about Message Analyzer and what it is. But before I even do that, I want to talk about just what people in my profession consider sniffing on the wire. Why would you sniff on the wire? What do you see? We get to see packets, but let's talk about why we might do that. It's kind of interesting here. This is a tool that one could argue is used by professional network engineers. But there's a perfectly rational reason to use this at home as well. Anyone ever had a problem with their phone connecting to their home Wi-Fi? You know, is that something you recognize? You know, does your wife give you a hard time because her computer's not connected to the internet? All of this is good stuff, and that's exactly what sniffing on the wire is all about. So before I do anything, I'm just going to, a good part of this is going to be demo. So let me just skip to, so all I want to do here is I've got the message analyzer, I'm just going to do a restart, and all I'm doing here, right, is all I'm doing is collecting packets that are on the Wi-Fi network at Microsoft here. And if I just say group, you'll get to see, and all we're seeing is, down here is protocols, and the counts and the numbers are packets of that protocol as they pass across the Wi-Fi network, okay? It's quite scary just how much is there actually. You know, I'm not doing anything, just to be clear. I'm just sniffing on the wire. I'm going, well, what's there? Many years ago, before I joined Microsoft, I worked for the European courts. I was hired to prosecute Microsoft. And I was sitting at Seattle Airport with one of my colleagues, and we were both sniffing the wire in Seattle Airport. And this woman came up to us, and she said, "Are you guys on the network?" And we both looked at each other and were thinking, that's the one from Google that just typed her password in free text. And we were thinking, well, yeah, technically we are on the network. But not in the way that she meant, of course. She says, I'm having a problem getting on the network. And it turned out at that time, Seattle Airport, it allowed 256 people to log on to the network. Then when the 257th came along, it just booted the first one off. So, of course, there was a lot of people wandering around going, why am I keeping disconnected? Because there was like a whole pile of people waiting for a plane at that time. So, really, this is what it's about. This is protocol analysis is really what it's about. If you imagine two computers connected with a pipe and the data flowing back and forward, really protocol analysis is looking at that data as it passes across, and then what we call dissecting the packets. And I'm just going to jump out of here for a second. I'm just switching. So I'm going to use this. This is Wireshark, which is actually, some might consider an open source competitor to what we do. But the analogy I always draw to this is Message Analyzer is a network tool. And the way I describe it is like, you know, you've got a toolbox, and I'm sure some of you that do things around the home have a toolbox full of tools. And Wireshark's a tool. Netmon, which was an earlier Microsoft network analyzer, was a tool. A message analyzer is just the new shiny tool. Okay? I don't know about you guys, but when I get a new shiny tool, I don't always get rid of my old tools. I tend to keep, you know, a bunch of tools around. Yeah, sometimes I like my old tool. Sometimes I need two really big hammers, you know. So it just depends what you want. But what I wanted to show you here is, I'm going to show you this network trace, and you can see this looks a bit unpleasant, actually. And what this is actually, if you can see up here, it says robocopy. This trace is actually a copy of a file using a Windows utility called robocopy. And if you see down here, occasionally SMB2 appears. And then you get a whole bunch of TCP fragments, in essence. And if I keep going down here, every now and then you get some more SMBs, okay? So you can see that it's, and you notice that's a read response and that's a read request, and then you get a whole more TCP. And when we were working on Message Analyzer, this kind of bothered us because this stuff's really hard to read. So if you're sitting there thinking, I might rather have a sleep than read this, then you're not the only guy, okay? We thought that as well. We really wanted to do something better. We said, you know, this is pretty darn ugly and it's really painful to read. So let me just take that exact same trace. I'm going to close this one, say close without saving. And I'm just going to go and open. And hopefully you can see that the trace looks a little bit different. So you notice that all you're seeing is SMB, SMB, SMB2, okay? So it's all kind of compressed. You see there? So we're just seeing SMB2. We're not getting all this TCP and other stuff. Now it turns out if I drill into this, if I just drill in here, and I drill in there, and I drill in there, and I drill it at some point, I'm just trying to find a good, let me do it on there. You actually, just by clicking on it, I can actually see that that's made up of the broken down input. So you can see TCP, and it says it's reassembled. So we've actually taken all these other bits that you saw in the earlier trace, all the ones that were separated off, and just collapsed them down to one packet and said, actually guys, I know you've got all these PC bits lying around, but that's really hard to read. And really what you have is actually one SMB packet. And that's really what you're getting. So what we've done is we've kind of abstracted it to a higher layer. We just made it easier to read. And just, if I show you, hopefully this is clear, you see how some of these are green and some of them are blue. So the blue one is actually what we call an operation. So what we've actually done, the tool actually finds the read request and the read response. It goes and searches through the trace and it finds the two and it pairs them up for you. Okay? On the older tools, Wireshark and Netmon, you had to kind of rummage around and find it yourself and then go and look. And of course, depending what was going on the network at any given time, you know, if there's lots of traffic buzzing around, that's kind of hard work just to go and find them all. Okay? So this just, you know, that simple act alone of taking all the fragments, putting all the fragments together, putting it as one packet, and then matching up the request and the response just makes life so much easier to see what's going on. So really that's what my talk's about. I'm really going to talk about what we did with Message Analyzer to make life a bit easier. Hold on, this should be coming up. So, packet analyzers. I've talked a little bit of this so we can see. You say what a packet analyzer is, so that's what I just showed you. I showed you the early version, which is Wireshark, and I've showed you Message Analyzer, which is the new one. Okay, basically it just analyzes traffic on the wire. Nothing very clever, but kind of handy. Sometimes, as I say, if your home router isn't working or you're watching streaming media from the internet and it sort of craps out on you, then this is the sort of thing you want to go look at. As I say, the early one, Wireshark and our older tool, Netmon, they acted as dissectors. So what would happen is you would get the packet, and then it would show you the structure. You could kind of drill into it. If the thing was made up of 10 fields, it would show you what each of these fields are. And that was pretty useful. You know, if you're either analyzing a protocol or you're writing software to make a protocol happen, being able to do that was pretty helpful. And this is just what I showed you before. You can see, you know, it identifies the protocols. Occasionally, if you notice the unknowns there, occasionally we simply don't have parsers for the protocol, i.e. it's a new protocol or someone didn't tell us about. Now historically, if you go back to earlier than 2006, a whole bunch of the Microsoft protocols would have been in that category. You know, and since then we've published something like 500 specifications describing every one of these protocols, and we've also written parsers so that anyone that uses or even is just analyzing what Windows does can pick up one of these tools and go over, look and do the analysis. But we went a little bit further, and we no longer just simply dissect. If you think of a packet going across the wire is a bit like a data structure. You know, it's got a bunch of fields in it. Message analyzer can do what we call validation. So it watches the traffic. So it doesn't just watch one packet at a time. It watches them all, and it builds a model. Inside, builds a protocol model. And if a field, say, just imagine a field should only have the values between 0 and 20. If it actually sees on the wire of that field that should go between 0 and 20, having, say, 40 in it, it will complain. It will say, validation error. That protocol's cheating. It's not complying with the specification. So now it actually warns you. Because we used to put a lot of effort into doing that warning. I mean, in fact, the Samba guys, we touched a bit, Samba is a piece of open source file sharing software. They had a really long running problem with one of their protocols they couldn't figure out. And we loaded they had a Wireshark trace. We loaded up the Wireshark trace into Netmon, into Message Analyzer. And literally, we loaded it up and there was a red cross saying, there's your problem. And they'd spent months trying to analyze this. And so letting the tool do that analysis rather than the human really makes life easier. So just when we say dissection and abstraction, so we've abstracted, what we mean by abstracted is we bundle up all these packets together and just make them easier to read. That's really and the operations, when we bundle together groups of operations into their into a kind of logical pattern. And I mean, I don't have an example here, but LDAP, for instance, when you make LDAP, frequently you get one request and maybe 20 responses. And actually it bundles them all up nicely as well for you, so you only get the one request and all the 20 are. So now you don't have to rummage through lots and lots of trace to go find it. A few other things we can do, I just want to show off really. So we do protocol validation. We can also do data capture from other sources. Wireshark and Netmon traditionally capture what we call NDIS, i.e. network traffic, okay? Which is, you know, most protocol analysis in the network traffic. But as we've seen, the world's kind of moving to a different place. You know, mobile technology, pretty common. Bluetooth, very common. Bluetooth, pretty hard to diagnose. We can do, let me just skip, I was going to just show you how we can do it. So we can pretty much, wait a minute, wrong place. And I'll just show you, I literally can click on here. Oh, it's not showing. What's happened? I lost the graphics. Hold on. Better, much better. Okay, so I just show you, and I come in here. By the way, I've not said it out loud, but this tool is freely available for download. You can just go and grab a copy yourself. And a bit of what it doesn't do, by the way, is diagnose graphics faults. I think I could do with one of them right now. Nope. Struggling here. There we go. If I say capture, I can literally just go here, click on Bluetooth, and you'll see that it's got these drivers, and I'm going to talk about them in a moment. But basically, the way Windows has this capacity to do an advanced form of logging, and we call that ETW. event trace for Windows. And really it's just a fancy debug. It's debug with XML, and we just know that if text is good, XML is better, of course, don't we? It's always true, isn't it? I am joking, of course. So this literally, I'm not going to do the Bluetooth demo. I'm just for the sake of time. Yeah, let me come back to the thing. I've got an image I can show you. So just coming back here for a second. So you can see we now have the capability to capture from a whole bunch of other places. We can do web proxies, which allows us to capture HTTP and HTTPS traffic and decrypt it. Okay, mixed blessing decryption. You know, we would all like to encrypt our traffic so the government can't spy on us. On the other hand, if you're a protocol engineer, you would quite like to decrypt it. They're a bit sort of inconsistent with each other. We can do USB ports, so we can capture USB traffic now. And you know, if you're into, if you produce devices that do USB, being able to diagnose that. Now, there's some pretty high-end tools you can buy for doing USB diagnostics. But message analyzers are kind of cheap and cheerful. It allow you to capture the traffic on the USB bus and analyze it. Sure.
Now the network speed is going up to 10 gig, even 40 gig in the future. How are you able to manage that?
I should give that man the money. That's what we call a nice segue. We have an answer to that. So the question, just so as everyone answered, there's true network speeds are getting faster. In fact, first time Microsoft has this cluster in a box system, and you can put 3 30 gigabyte network cards in it. And then you can gang them, so you can group them together. So you can actually get 90 gig a second. Now, it turns out if you're at home and you want to copy DVDs, 90 gig a second is a really great thing to have. First time I was on there with Message Analyzer, I discovered that a really important design was the distance between the start capture button and the stop capture button. Because when data's coming at you at 90 gig a second, the length of time it takes you to move the mouse means your hard disk is getting filled up really fast. So the way we answered that is we have this mode of data capture called header only. Okay, so when you think of a packet as it's got this header on it and it's got a whole bunch of data on it, and what we basically do is just throw the data away. We keep the header because from a protocol point of view, that stuff's useful. The raw data usually not so useful, but you know. So we do have a bit of an answer, but honestly, it's still a problem. You know, you just do the simple arithmetic on that amount of data. You know, you have a problem with where do you put it. You know, 90 gig a second. Where am I going to store it? That's kind of scary. You know, but so we're trying to tackle that. That's one of the challenges we face in the modern network is what to do with that. There's other things we can do as well. In the case of Windows, I believe from an earlier conversation, and I wasn't in the room, there's a few people in this room that are interested in SMB. But one of the things we can actually do is the SMB client, so this is the software inside Windows now that is the client software, is actually instrumented so that it emits debug as well. And so now you can actually capture the software itself emitting what it's doing as well as the network traffic. And for our support engineers and people, that's pretty nice because now you can actually see what code's being executed and what network traffic you're getting. Just a little bit more about event trace for Windows. This is one of these kind of ugly ducklings in Windows. There's a whole bunch of ETW stuff in there. And if you go and look in the event log, there's a whole thing. The truth be told is Message Analyzer makes use of maybe a dozen, you know, about 12 of the ETW providers. There's probably the best part of 100. And we're still working on both what do these ETW providers give us in terms of debug information, and can we turn it into something useful to help people? And honestly, we haven't got the answer to all of that yet. But this is just giving you a little diagram. if you're interested in ETW, there's a stack of it on MSDN. But basically, these are built-in providers that are built into Windows. If you just think of them as debug logs built into Windows, you can, if you're having a problem, say, with Windows logging on, there's a net logon provider. Most of the time, we're using the NDIS provider, i.e. we're trying to capture network traffic. So that's the one we use. There's a USB one, there's a Bluetooth one. That's how we get at all these other types of traffic. There you go. There's even, when we dish this out, I've put the link on so you can, if you're interested. Just show you, rather than use the tool, it's kind of this is just showing you the top of the pop-up of the event provider. So you can just see there's a Windows firewall service, there's deduplication, I don't even know WSD, Brian, you must know what that is. WSD API, do you know that one? So some of them I don't know, OLE database, kernel trace volume logs. There's literally stacks and stacks of these that have potentially useful information in them, depending what you're interested in. Got here, just show you, remember I said that the parsers can do validation. This is just showing you this is the validation column. And this is message analyzer passing judgment on these packets. The red cross basically is telling you, hey, something's seriously wrong with this protocol packet, it violates the specification. We get these lesser ones that are like an exclamation mark, and then we just have some simple information. And so there's just like classic debugging type thing, there's degrees of warning levels that saying, this one looks suspicious, that one's definitely a problem, this one, here's some information. So one of the other things we found that was a problem for us is that network software is a bit of, network analysis software, like the message analyzer, is a bit of a pain to install on machines. And what we really wanted to do is just, usually what happens is there's a machine, I get a phone call, I'm in support, somebody says, my machine's not doing X or Y. And what we've now done is we've built into Windows the ability to do a remote capture. So if I know the name of a machine on the network, I can simply do a remote capture. I can connect. I'll come back to this in a second and try and do a demo because this projector's messing up a bit. I'm not going to flip back and forward. But basically this just allows me to say, that machine over there, let me connect to it, collect a bunch of traffic, and bring it back to my analysis machine and do the analysis there. It means now you don't need to install extra software or the analysis software on an average user's machine. You can just simply log in, capture the data, pull it off. Okay.
A very simple, quick question. The NIC card, should we have something called the prosecutor mode?
Sorry, the NIC
card?
card?
The NIC card has certain feature, right? You're able to do
that.
that.
No, you can get that as well. Yeah, yes. Yeah, he's just asking if the network card has some specific features, and you can tweak these, yes. I'll show you in a moment. I'll come back to that. This is just showing you an example of the sort of traffic you get. So this is a little capture I did. All I did was I paired my Windows phone's Bluetooth, my HTC, must be made in Taiwan, is HTC, is it? Paired it with my laptop, and I captured the traffic at the same time. And in the same way, you see, it just treats Bluetooth as another network protocol. Again, I get a breakdown, and I can drill into that and see the packet. Okay, so Bluetooth, we don't really mind. It's just the same as anything else. And USB is the same. We can simply treat USB like any other network packet. The other thing Message Analyzer does is we can simply load Windows event logs. I don't know, anyone here ever look at Windows event logs? Yes? I don't know. You must be the only sad person in the room. The other sad people aren't really admitting it. There's a few others. It's one of these kind of horrible evils. You know it's there, but you don't really want to look, do you? And to be honest, they're a real pain at times. Just finding any data. One of the things that the nice thing is once you load it up into Message Analyzer, you can kind of sort it and search it, Again, it highlights any errors so you can find the critical errors quicker. Quite often you find event log, you have to page through miles and miles of junk to find anything useful. And at least, so you can just load them up. The other thing that it does, Message Analyzer does for you, is that event logs are not very portable between machines. And if you load it up into Message Analyzer and save it in Message Analyzer's native format, now it does become portable across Message Analyzers. Another thing we can do, and I am going to dive out here and try and do a little demo. So, one of the things that we discover that when we're doing debugging and networking analysis is that you frequently want to look at more than one piece of information at one time. You know, maybe you've got a log of some form and you've got a network trace. And what you really want to do is put the two of these together. And I'll just show you, in this case, I've got a Samba syslog, so non-Windows completely. This is off a Unix machine. And I've got a Wireshark trace together. And so I'm just going to select both of these. And then I'm going to say, what's it doing? And it's going to pull them in. And you see, when I scroll down here, if I scroll down, oh, well, actually, let me just group it. It's probably easier to do at this point. No, that's not very nice. I messed that up. Hold on. Let me put the microphone here. So all I wanted to show you was that if I page down at this point. So I have this log file, and at some point I can get the network trace as well. And what I can actually do is I can intermingle based on some field, like time would be the most ordinary, most normal thing. I can intermingle a log file based on time and the network trace based on time, and we can correlate the two together. We've got some tools as well. If you collected a log from one place and a network log from another, sometimes the times aren't quite right, and we've got a kind of nudge facility that you can just move the time of either the log or the network trace back and forward a little bit, so as you can align two events. And hopefully, once you've aligned a log event and a network event, everything else will kind of stay in sync. So we've got some nice correlation technology there as well that just helps. So just virtually on the screen it shows you get these Samba headers that are coming from the log, and then you get the network session that comes out of the network, and you see that? So these are from the log file, and then this one's actually the network trace. So we've now, in this case, what the Samba guys were doing, they had debugging their code, hence it's showing C files here. And so now you can tell, well, actually this line of code executed right here. So that allows you to correlate your network traffic with your code. So again, this is just an example of correlation at work. So that's what we call the browse select view. You can actually load more than two things as well. You can actually load a bunch of things. It gets a bit challenging if you get too much information. There's a couple of other things. Back to the question I was asked earlier about what do we do with really big data. So assuming the data wasn't so crazy that we could actually get it on a hard disk, we actually have the ability to say, open that file over there, but only give me this slice in the middle from time A to time B. So now you just get a small slice. So you can kind of go through a log file just looking at the window rather than trying to load up the whole thing. And that's another thing we're just trying to help us deal with these really big files. Again, that's just one of the challenges. Let me just, I'm going to one more time, I'm going to go in there. There's a cut. Oh, I've lost the screen again, have I? Okay, I'm going to live with it. I'll come back in a second. Just, if you haven't seen, we've talked about this a few times in this Plugfest. If you haven't seen these, if you're kind of new, the Windows protocols are all published on NSDN, okay? So we have parsers in message analyzers for most of these. There are some protocols that are kind of like so old and kind of nasty, it's probably the right word, that nobody ever looks at them. But the majority of the ones that as of Windows 8.1, they're all documented there. And we have parsers for them, so you can go and capture traffic and understand what they're telling us. Message analyzer, if you want to have a go, there's a link for you. You can go and get it, or you can just use your favorite search engine, which I'm sure will be Bing. But you can just Google or Bing message analyzer, and you'll find a download from it. I would strongly recommend, if you are going to play with it, you put it on a 64-bit machine with a reasonable amount of memory. It does, if I'm really honest, it doesn't play that well on small amounts of memory. And particularly if you're trying to do big network captures, you kind of need to have big memory for big network captures. Yeah. Let me do a Q&A. Let me just come back one more. I just wanted to do a couple of other demos, but I need to fix this screen again. So we have a bunch of other things. I just I'm looking for new viewer. For instance, I can do a protocol dashboard, and I just want to show you. We've got these dashboards, and so this is just giving you a kind of an alternative form of looking at network traffic. It's kind of handy. You know, if I'm trying to do a network capture and there's one protocol I want, rather than having to read one line at a time, this view is much kind of easier. I can kind of sit and just watch for the traffic that I want. I can kind of do this in real time as well. Let me just try it. And you'll see literally I can sit and do network traffic, and I can just watch in real time the traffic as it comes in. Okay, and that, you know, that in itself is pretty interesting. You know, one thing you do want, if something turns up as unknown, for instance, I'm a Windows protocol guy, I'd be a bit concerned if there was something unknown and all of a sudden appearing. But you know, you can look for patterns. You know, in fact, if you know what you're doing, you're a bit practiced, you can actually tell that there's like unwelcome guests on your network, for example. So there we go. That's really all I've got to say. I want to encourage people to go give it a play. You know, go grab it, go try it. We'd love to hear your feedback. Right.
What about RDP?
What about? Oh, that's a prompt. This man's doing a sales pitch on it. Actually, Brian is going to show. He's going to do a talk on RDP protocols later. I believe I'm right in saying you're going to show us a bit of decryption as well.
Yes.
So one of the things that, for those that work in RDP, RDP is the Terminal Services Protocols. Normally they're all encrypted, and we've got a kind of new on-the-fly decryptor that Brian's going to show off. It was both a good and a bad thing. He got this working quite recently, and of course, the minute you get that working, a whole bunch of protocol parsers starts to get used that hadn't been used before, and we found a few bugs, I think it's fair to say. Is that a fair statement? Yeah, so you're going to hear, if you get specific interest in RDP, you'll hear more from Brian. When is that? Tomorrow. Tomorrow. Okay? Thank you for listening.
好，谢谢你哦。